Hi, my name is Joel Matthew. You are 15CS177, and today I'm going to be explaining my 8th experiment from Unix and Linux lab. So the experiment is actually to do process creation. So for that we are going to be using the C programming. So my first question is to actually create a child process, and in which the child process does addition and the parent process does subtraction. So I'll show you the program over here. So this is our C program. So we have the header file and the main function. So inside the main function, we have to take two inputs, A and B, and then we have to take the process ID. So for that we have to take PID. We have taken ID, and then ID equal to fork. So this returns the process ID. So if ID is equal to 0, that means we are inside the child. So inside the child we do the addition operation for A plus B, and then we give the child PID by using the function get PID, and the parent PID by giving the function get PPID. And then once we go in the else condition, we are in the parent. So in that we use this wait function for synchronizing, so that the child is not orphaned, and the full execution of child is finished before we execute the parent. And once we go into parent, we have to do subtraction, and then we get the PID of the parent using get PID. Now I'll show you the program. So we'll run the program once. Sorry. So we compile the program, and then for output we have to put ./.a.out. And once you do this, it will ask the first number. I'll enter it as 15, and then it will ask another number. We'll enter it as 4. So as you can see, the addition result, this is inside the child. So we have addition result, the child PID and the parent PID, and then in the subtraction result, and then the parent's PID. So as you can see, these both are the same. So it shows that the child was executed perfectly, and then after that the parent was executed. So now we'll see the second program. So in this program we have to actually create a child and a grandchild. So initially from the parent we have to take a string, and then inside the child we are going to reverse the string, and inside the grandchild we are going to show the capitalized version of the string, input string. So this is my program. So over here we have the necessary header files. So for string functions we need string.h, and for to lower, to upper, and all those functions we need ctype.h. So since we are creating two processes, we have two process IDs which we have to initially declare, and then we have two arrays for getting the string characters or the string. So we enter the string which goes inside the array, character array A, and then we make a copy of that character array and send it to B as well. So we get the length of the array and store it in len. And now we create the process. So first we create the child. So in the child, using fork system call, we create the child. So once we go, if the ID is equal to 0, that means we are inside the child, and over here we do the reversal of the string. So all we have to do is actually just enter the array in a backwards order. So that's what we do over here, and then after that we display the child PID and the parent PID by using get PID and get PPID. And then after that, inside the child itself we create the grandchild. So ID1 equal to fork. So if ID1 equal to 0, that means that we are inside the grandchild. So once we enter the grandchild, we just make it uppercase by if we have a small a and small z, that means we have to make it we have to make it upper by using the to upper function, which is given by ctype.h, and then we enter the print the grandchild and the parent PIDs, and then we have once we in the else condition we go inside the child, so we use wait for synchronization, and then in the next else we go inside the parent. So inside the parent we will display the original string as well as the parent PID. Now let's see the run the program. So it's asking for a string, so I'll enter my name. So as you can see, first we enter B, which is the child child process. So inside B we get the reverse string, then we get the child PID and the parent PID. Once this is over, execution is over, we go inside the grandchild. So in the grandchild we get the uppercase of the input string, and we get the grandchild PID and the parent PID. Now the child PID over here and the parent should be the same, and this, and then once we exit the program process C, which is the grandchild, we go inside the child process, which is B, and then once we exit B we go inside A, which is the parent process. So inside the parent we show the original string and the parent PID. So as you can see, the parent PID over here and the parent PID over here should be the same, which it is. So the program is successfully created all the processes. So thank you for listening to me.